Today we have a box opening, and this is a dual box opening. This is a repair that somebody sent in, and this is supposed to be out of a Silvertone console stereo from the 60s. One is supposed to be the amp, the other side the AM/FM tuner preamp thingy. And if I remember right, the complaint was AM worked good and there was very low to no audio on FM, but there was barely reception heard in the background with the volume wide open. I think that's what it was. And alright, I like to do these videos for my own documentation as well as everybody's enjoyment. This thing is, looks like it's and that's the other thing I tell people: if you're gonna ship it, you better pack it you know, to be able to to survive a 5-foot drop or something. It's a Silvertone stereo.
A Silvertone, they still make that?
No, it's from the 60s.
Yes, I know the name.
Very nicely packed. See, we've got the knobs there. Lots of tape. Okay. So this is not even stereo, is it? No multiplex decoder. It's got the cool tuning eye there. Alright. Okay. Here's the power. Now Silvertone should have a tag somewhere that gives us the model. There it is right there. 528 53580. Our FM tuner tubes are missing. I'm sure they're in here somewhere, probably. Oh, they're in there, okay. Well, this is a serious packing job, and not much in the way of capacitors. We got one there, one there, one there, one there. And what is this for here? FM antenna, AC power, AM antenna. A lot of diskies. A selenium. Now the owner was kind of in that spare no expense, I want this thing to work flawlessly for years to come. So we can attempt to do that. Alright, here's opening the amp. Oh, packaged vacuum bulbs. Knobs, don't need those. Geez, this is like a professional shipping, like something you'd buy new. Let's get this unwrapped. Alrighty then. Six BQ5 outputs, 12AX7 phase inverter. So it's 6CA4. That'd be the rectifier. Look at this, it's all disc. It's got a couplet there for the tone. All disc. Built to last. Yeah, I hear people say all the time, well, you know, you don't want to use disc capacitors in your old AM radio and the audio circuit and all this stuff, and you'll never hear the difference. It's the people that talk about using polypropylene capacitors versus mica film, or versus paper capacitors, or if you change the circuit breakers in your electrical panel, your sound system will sound better, and you need to break in your speaker wire after you install it. Got to put some miles on it before it sounds right, and got to have 4/0 speaker cable to go 5 feet from the amp to the speaker, and you know, all of that nonsense that we hear from the audio fool crowd. Alright, the vacuum bulbs have been populated. We got a speaker output there. We got a ground here. I guess that's for external speakers. Left and right here. I guess this is one of those that has the stereo turntable and the mono AM FM radio, which, whatever, multiplex was never that robust and that stable on a tube thing anyway. That's why Zenith went to solid state pretty much as soon as stereo came out, because it's just too hard to keep the tubes, the phase alignment of the pilot carrier and that, in order to keep good stereo demodulation on a tube set. They're just too much fluctuation, too unstable. So I'll populate these bulbs and then we'll fire it up and see what it does.
Covers the world next. Frank Motek here, delighted to tell you about my BMW 7 Series, the ultimate driving machine. Spread some holiday cheer this season and get behind the wheel of the 750 Li yourself. It's the best car I've ever had, and it means business and fun here in Southern California. If you have a passion for driving as I do, you'll absolutely love it.
Well, I guess that's AM.
Love the outstanding power under the hood and the superb smooth, rock-solid ride on the freeways. That along with the outstanding harmony.
Varias según el crédito. Los comprados el nuevo del 2016 del concesionario. Y anoche del 4 de enero, los precios individuales pueden variar por concesionario. Las ofertas pueden variar.
Boy, if that's all the output it has, that's pretty sick. I mean, the airplane is louder than this thing, and you should be able to run this up into clipping really easy. Let's see. And there's only output out of one channel. I got the balance in the middle. Oh. Okay, I have a Packard Bell like this where you have off AM, FM, AFC, FM, and then stereo AM, FM, where it'll play AM in one channel and FM in the other channel, the old stereo simulcast. Now there's a good way to get true separation. So I'm not getting anything on stereo AM, FM, but I am also not getting anything out of one channel, and FM is totally dead, and AM is very weak.
5 stars. Fantastic race. See you at the starting line. No traffic.
Let me double check everything and make sure. You know, one side of this is quite alive and the other side is dead. Wonder what's going on with this thing. Guess I better start with the amp and get the left and right ironed out first. See if I could get a schematic on it, I guess. Here's what we're working on, and it's from 1961, 1962. And I'm going to take this in the house and photocopy it so I don't cover it with nasty fingerprints. Where is the amp? And I made an error earlier. I said a phase converter. That would be for a push-pull. This is not a push-pull. So let me photocopy this, my little scanner thingy, and then we'll do some voltage checks. Isn't that exciting? Alright, as for the entertainment value, we will try the Nixie valve bulb meter. And I gotta try and figure out how to remember how to use this. This is a Fairchild. Volts DC 100. Guess you could put it on auto range, and I got this fed into high. Nixie valve bulb meter. See what kind of voltage is. Well, we have 280 on the plates, so I better go up there. Alright, I'm going to start down here on the power supply. Will that focus there? And I should have, I'm going to try that 320 volt line there, and then we'll try on the other side of the 220. So we should have 290 and 270. Let's see. Alright, that is our 320 volt. Our next one is this one, which should be 290, and then we should have a 2200, and we should have 270 here. So they're all a little high. Who knows? It could be the Nixie valve bulb meter. Who knows? Okay. Next, I want to check the plates of the two tubes, which are pin 7. Let me pause and find that. Okay, here's one of them. It's supposed to be 280. Again, it could just be this meter is way off. Trying to find the other one, which is right here. $299, okay. Alright, pin 3. This is supposed to be 10 volts. It's 8.1. This is the cathode of the first one, EL84. This is the second one. Looking good there. Okay, now what I want to do is I want to check the plate there, which is supposed to be 90 volts, and the plate there, which is supposed to be 90 volts. Okay, that ain't right. That's pin 1. So we got a 270K there. Should be 270 volts on the other side of it. That is a red, purple, yellow. Why is that low? What is going on here? But it was measuring good over here. Oh, it's not now. Huh. We have a problem with the meter. If I put it on auto range. Alright, this is when you start wasting time on crap. So it's obviously off there and it's on there. Look at that. 280.5, 281. 281.1, 281.4. So that's kind of interesting. Okay, back to this plate. So we got 281 there, and we're supposed to have 90 here, and we have 43. So that could indicate that resistor is too high. Let's check pin. That is checking R51 right there, that 270. We have 280 on one side and 40 volts on the other. Let's check R38. Should be the same. Let's see, pin 6. Pin 6. Hello. Well, on that one we have 280 on one side and we have 0 on the other side, and that is the channel that there's nothing coming out of. So have these resistors just gone open? Let's power down and check it out. Okay, here we go. This is the that's the first 270. This is the one that we obviously have some leakage through here somewhere. And this is the other 270. Alright, we got 2 open resistors here. One of them is just, the one with 40 volts is just measuring 3 megs. It's just got some leakage going through it. And the one that was measuring 0 volts on the dead channel is just open. So, very irritating. Okay. Okay, that's the one that's measuring 3 megs. That's the one that's measuring open. Okay, there's nothing wrong with the meter. I'm just being a total idiot. So 43 volts, that's what it is. If I hook it to 280 volts, and that's accurate, 282, and then I go down here to 100, the overload light starts flashing. So I'm just, problem exists between keyboard and chair. It's my issue. I've been going through this thing. The vast majority of these resistors are all out of tolerance, like big time out of tolerance. I wonder if they use the same supplier that Philco used, because this is pitiful. What I might do is spot check a couple in the tuner real quick. That could be the problem with both of these. So what I'm going to do is I'm going to go through and get all new resistors for the amp. I'm not even going to touch the caps yet. I want to see it work first, and then we'll go after the caps. Let's spot a few, check a few of them in the tuner. All it would take is one plate resistor to be open in the IF, and it would behave like this. Well, there's nothing to the AM part. You got a 6BE6 AM converter, and you got a 6BA6 IF amp, and then you got a detector diode. There's nothing to it. It's basically 2 tubes. It's a 2-tube AM radio with a diode detector, probably germanium. And the FM is much more complex. You got the entire FM tuner, and then you got two IFs and an FM limiter, and then you have a 6AL5 for the detector. So,
response to the leak. This is Ed Mertz reporting. The declaration request comes from County Supervisor Michael Antonovich.
Anyway, I'm working on it. I hooked it up to just some PC speakers. I used a little 0.1 capacitor to isolate it. If there's possible voltage coming out of here, I should check that. Let me look at the schematic. Yeah, this is not isolated, the output of this thing, so I do have to use a capacitor in series with the PC speakers. I just don't want to burn them up. The isolation capacitor is on the amp side. So anyway, the AM, these are low impedance, this is high impedance, so it's probably...
As you make your way into then in downtown LA on the
I mean, that's the volume all the way up, so it's pretty bad, but there's still absolutely nothing on FM.
New brother reported on the 5th.
FM is just dead. So this is the FM tuner. This must be the first IF, second the limiter, and then the 6AL5 detector. So I guess I could put the signal tracer on it. Will it do FM? I don't even know. I imagine it would probably pick something up out of it. Alright, we're going to check this. Should be 130, 110, and 95.
So, when it comes to foreign currency exchange...
Yeah, we got a bad selenium, that's for sure.
A world leader in online currency exchange.
Should be 110, and this should be 95.
Hedging tools such as limit orders and forward contracts, as well as...
It drops in 3 steps.
At US Forex,
130 through this resistor, 110 through this resistor, 95. So this thing's got to go.
Perfect bank alternative. If you're tired of being hit by endless wire fees and terrible exchange rates, US Forex
So here's
is for you.
where the
US
feed
Forex
comes out of the tuner
support, faster transfers, and better rates. You also get
through that tube,
your bottom line.
through this IF transformer, back into pin 1, through that tube, through that transformer into the limiter, then from the limiter into the detector. Let's try the signal tracer. We'll just basically go put it on FM and go check some voltages first. Okay, so pin 5 should be 85, then 90. These are the plates. Then 60. Alright, so we were looking for 85. Boy, that is weird. Guess because the light is strobing, it's causing a black bar here. That's kind of weird. 1, 2, 3, 4, 5. 68 volts. It's low, but the B plus is low, so I'm not going to stress over it. You know, it should still do something. 1, 2, 3, 4, 5. 74 volts. 1, 2, 3, 4, 5. 39. That one's 20 volts low. But that's okay. This is 20 volts low. So it should still work. Alright, so we'll just start at pin 1. This is coming out of the tuner. Nothing there. So we'll go down to the next stage. Obviously the front end is working, so where do we lose it? Here's the next stage.
Network vivid, and they are actually kind of playing a market. But they'll be able.
What is this? Someone replaced something here and never cut the leads off? What kind of annoying thing is that? So wait a second, we got it. We got it there, and then we come here. And there's nothing here. What is going on with that? So it would go through this IF transformer right here. So that would indicate that tube is bad. Yeah, this light is too bright. Shut up. Okay, what I've done is I pulled that tube out and I moved the third one into its position. I don't think I've ever seen one of those just go completely dead, but we'll find out. No, something's going on here. This doesn't like the B plus on it. I got a capacitor. Alright, what I've done is I've isolated this with 1,000 picofarad capacitor.
Tom Wilson. Biff was that guy who liked calling people, especially Michael J. Fox.
So that's the grid coming out of the... This is the input to the first tube. This is the output. So you can hear there's amplification there. It's picking up 60 hertz hum off the plate voltage or something.
Yes, I was in the movie. You're all sitting there. That's not good. Back to the Future.
So we obviously have it through this IF transformer. We have it through this tube. And then we do not have it through this IF transformer. Nothing passing through this IF transformer. Wonder if it's got silver mica disease. I guess we could ohm it out, but we already know the primary's good because there's plate voltage on that tube. Well, we have 3.5 ohms on that side, and we have about the same on this side. .3 ohms. So essentially what we have is we have a signal the signal coming out right here. This is that shielded wire dumping in there. Then the signal's amplified and dumped out of pin 5 through the transformer. And it's coming through this transformer into this tube, and then the signal's real nice and fat here on pin 2 going into the transformer from the plate, and there's no signal coming out of 4 into the next tube. So what happens is there's these capacitors. See these capacitors that don't have a value? A lot of you already know this. This is, if you restore old radios, this has become a very common problem. It requires microsurgery. It's a bit of a pain in the ass to actually do it and get it right. Basically what we have to do, these capacitors are silver mica wafers, and the silver will decompose and migrate and bridge the thing or whatever it does. It's like corrosion that grows. And what you have to do is you have to take the transformer out, you have to disassemble it, and these capacitors are a wafer in the base, and they're actually a very precision capacitor, because any drift at all in this thing the alignment will go all over the place. So you really can't even use disc capacitors here because they drift too much. So what we have to do, the way we're going to do this one, I think, and this could change, going to have to take that transformer apart, get these capacitors out, and then once the capacitor thing is out, then what we do is we put them on the bottom of the circuit board. And probably what I'm going to do, since the values are unknown, we could guess they're between 39 and 47, somewhere in there. But they're hypercritical. 2 or 3 picofarads will really throw it off. What we'll do is we'll get 2 variable capacitors, and we'll solder them across the bottom. And we're not going to try and tune the slug. We're not going to touch the slug. We're going to assume that it hasn't been touched and where it was coming from the factory. And then we'll adjust the capacitors to bring it into tune. So this is going to be this will be a good video, but this is going to be a bitch. This is a time-consuming pain in the ass. I did this. My first experience was on one of those General Electric, one of those cheapy, cheesy AM/FM radios, and I spent I don't know. I think there's 4 or 5 hours of video on it, and actually getting it right is very challenging. And then the question, of course, is how long is it before these go? You know, do you recap all of the IF transformers, or do you basically say, look, this is an extreme pain in the ass? It's also pretty risky because you're dealing with these little, you know, like 48 gauge wires that are thinner than a hair. And so I would be tempted to say to the owner, look, we know this is a problem. These are probably going to fail at some time in the future. They might not, but we'd probably be better to just go ahead and do the one initially, and you got to just pack it up and send it back if the other ones go, because there's a real risk involved with getting into these. Have I rambled on long enough in this video? This is part 1 of the Silvertone console stereo thingy. Let's get a picture of it here. There we go. And this is Shango 066. And tomorrow I'll go to the electronics store and get some resistors and capacitors. Well, this is pretty interesting. He says here, AM seems to work fine, FM doesn't work, but if you crank up the amp, you can barely hear it. I tested the tubes. RF amp tested weak, so I replaced them with new old stock. The yellow wire doesn't seem to... It doesn't appear to go, but it indicates someone maybe has looked at the unit before. That's an interesting take on that wire wrapped around the transformer. I wouldn't have picked up on that was somebody's mark. You'd think they just take a pin or something and, you know, right. Anyway, according, he does recognize the selenium rectifier. I don't have a Variac. I just turned it on. It wasn't too long before I smelled something burning. Well, that's, you know, that's the way we do it over here, so don't feel bad. I try and do these repairs in an unconventional way. I can, you know, once you watch 1,000 videos of people testing tubes and bringing things up on Variacs, it gets boring. So the way we do it over here is a little bit more brute force. We want to see smoke and fire and things exploding, hopefully. He says here, the radio was playing AM at the time and sounded great. The amp never missed a beat. Now that line there is very interesting, because as we see, the amp is only working about 25% of one channel. So I don't know what you meant by missed a beat. This thing doesn't have enough power to cook speaker wires. Yeah, this thing probably 5 to 7 watts, but they use those old school speakers that are probably like 110 dB at 1 watt. So this thing should pump. Both speakers on this should pump really loud and probably with a good amount of bass. This thing should rock the house. You know, this is going to be as loud as a modern 100-watt component system. Just because it's built to be more efficient. So I don't know about this thing where the amp never missed a beat. Maybe these old resistors have a thing with shipping and they go open when they they go on a ride across the road. I don't know. But to me, the amp is dead. Try a different camera and see if I still get the lines there. See, what am I in here? 1080, 60 frames. I don't need that though. I was looking at where those wires, those long uncut wires, were sticking through on the bottom here, and somebody changed that right there, which should be the detector diode, and it just looks like they used a big AC rectifier for a detector diode. Not going to be very effective, not going to be very efficient. Something designed for 60 cycles is not going to work at 455 kilohertz. We got to get the right diode in there. I'm going to feed the signal generator into the output of that IF transformer just to verify that it is in fact bad. And I'm going to try my new toy here that I bought. We'll get into this a little bit later. The one on the bottom there, the old school analog one. So I gotta try and figure out how to use this. Let's see, FM, 1000 hertz. Crank the deviation way up. And whatever. Frequency 10.7. And negative 127. See, how do we... No. I gotta remember how to do this. 10.7 megahertz. Okay, then we'll crank. There we go. I hear it. Boy, that sure seems like I'm putting an awful hot signal into that. Can I change that to volts? I haven't played with it enough, but I should be able to change it to, there we go, 316 millivolts. 1 volt. Let's see if it'll do 2.0 volts. Nope. That'll do 1.5 volts. Maybe that's right. You know, maybe we can hear it at 47 millivolts. I can hear it there. The main thing is it actually seems like it's more centered around 10.6 than 10.7, but who knows? Look at the eye here as I crank the voltage up. So anyway, that proves that it's that IF transformer. I could inject it on the, I don't want to do that because it's high voltage. I don't want to burn my new thing up.